Okay, welcome back. In this last lecture of new material for the semester, we are going to spend some time talking mostly about the impacts of warming, and I want to profile two things in particular. I want to talk about the impacts of heat waves, and I want to talk about the impacts of sea level rise on New York City. We're, of course, at the end of the semester here, so we're not going to have time to talk about all of the impacts of global warming, but hopefully this should give you a foundation of a couple of ways that we think about the future and how this change in just a few degrees of warming can have really profound impacts on the way that the world operates. So this is our overview that we've been working through for the last couple of meetups. So we have finished talking about is it warming and why is it warming. So we've covered those. Yes, it is warming, and it is warming because of all the carbon dioxide and other greenhouse gases that we put into the climate. What I want to talk about today is what are the impacts of this warming. Before I do that, I want to do just a couple of kind of last things with this is it warming thing. And most specifically, I want to show you some forecasts of the future and just statements from some scientific organizations. Okay, so this is Earth's climate is changing. So this is temperature data. So we have degrees Celsius on the y-axis and year on the x-axis, and you can see obviously this is a forecast into the future. So the black data here, this is data, this is observations of our temperature. And the red line here is warming if we continue emitting in a business as usual kind of a way. So we keep operating how we've been operating. We don't make major changes to the way we get our energy and transition toward more renewable resources and things like that. Then we follow the red curve, and the blue curve is what we get if we make major investments into our future. So what you can see is that we have committed ourselves to a certain amount of warming. And actually, we've committed ourselves in the next couple of decades to more or less the red curve and the blue curve are right about on top of each other, up out until, I don't know, the 2040s or so. So independent of what we do now, we've committed ourselves to a certain amount of warming. We have some warming that's just in the pipeline because of all of the greenhouse gases that we put up into the atmosphere. So if you remember, carbon dioxide doesn't just go away. It takes 100 or more years for carbon dioxide that's in the atmosphere now to cycle through and end up out of the atmosphere. So, and I put this up because the way that we follow the blue curve, which would be a different world, but something that would be a lot easier to adapt to, is by making huge actions now. And when we come back after the module test next week, we're going to investigate this a little bit more. Okay, so and also, right, we have control over this, right? These are two very different worlds. A world with 4 degrees Celsius of warming compared to a world with 1.5 degrees Celsius warming are very different worlds. What we do now matters. Here's some statements from some of the leading scientific organizations in the world that study climate change and global warming. The American Geophysical Union is said, a quote from them from their website is that humanity is the major influence on the global climate change observed over the past 50 years. Rapid societal responses can significantly lessen negative outcomes. The American Meteorological Society, this is a group of weather forecasters. It is clear from extensive scientific evidence that the dominant cause of the rapid change in climate of the past half century is human-induced. Remember, human-induced is anthropogenic. That's a word that I like there. Human-induced increases in the amount of greenhouse gases. And the AAAS, the American Association for the Advancement of Science, I think is what that stands for, is the scientific evidence is clear. Global climate change is caused by human activities, and it is occurring now, and it is a growing threat to society. Another group is the Intergovernmental Panel on Climate Change. This is the largest body of scientists worldwide that study to study climate. They have said that the warming is unequivocal. Right? There is no way to say that the warming has not happened. We have absolutely observed warming. Another quote from them is that human influence has been detected in the warming of the atmosphere and the ocean, the changes in the global water cycle, in reductions of snow and ice, in global mean sea level rise, and in changes in some climate extremes. The National Climate Assessment is a large assessment report put together that is United States centric. And a statement from that report is that it is extremely likely that the human influence has been the dominant cause of the observed warming since the mid 20th century. For the warming over the last century, there is no convincing alternative explanation supported by the extent of the observational evidence. So the reason that I'm going through all of these things is that I want to make sure that you all leave this class knowing that despite what you hear outside of the scientific community and the media world and speaking from people to people, there's no debate within the scientific community. Virtually all scientists who study climate agree the world is warming and that warming is due to human activities. Okay, there are some things that scientists don't know about. There's plenty of things that scientists don't know about, right? They don't know how much it's going to warm. That depends on what we do. They don't know how much sea level is going to rise. They don't know, right? There's things that scientists don't know for certain, right? So there are uncertainties, but there is no uncertainty on, is it warming? Yes. Is it caused by human? Yes. Okay. And I want to make sure I reinforce that before we go on to talk about some of the impacts of this warming. Okay, the number one lesson that I hope you will leave this talk today with is this one, which says that the impacts of climate change will be most keenly felt in situations that are already stressed in today's climate. So I want to go through some examples of what I mean by stressed situations. So this is a photo that I took off of my parents' back balcony. So here they are. They live in southern Utah, in a place where there's wildfires every year. And they're naturally occurring wildfires. I shouldn't say naturally occurring, but this is a region that is prone to wildfires. They happen all the time. They happen every year. This wildfire that I took a picture of is, oh, geez, I wish I remembered. I think it's like less than 12 hours old. So this was started by a campfire that didn't get put out properly, and the campers left. And that little campfire, in just 12 hours, took over tens of thousands of acres of land. Okay, you can walk out into the Adirondacks any time of the year and throw a match on the ground, and it will not start a fire that looks anything like this fire. But our ground is too wet. We are lucky to live in a climate where we get precipitation every month of the year. We don't have really long drought seasons. Out west, it's not like that at all. So out west, everywhere west of Colorado or so, for several months a year, from summer into fall, they experience drought every single year. And what happens when there's drought? Plants die and they dry out and they become kindling. And little sparks can start a massive fire. And this is a natural thing. This has been going on long before human activities had anything to do with it. But this is what I mean by a stressed system. So this is a situation that is already stressed in today's climate. Okay, this annual wildfires that happen naturally in this region, are already an issue. And what are we doing? We are warming the climate. So when you think about how warming the climate might make this situation that's already stressed worse. And here's what I see when I think that. Geez, a place that's already in drought, let's make it a few degrees hotter. So now a 95-degree day is a 100-degree day. That's going to kill more vegetation. It's going to dry out the ground even more than it already did. So we've taken this system that is already stressed, it's already dry and kindling, and we've made it even more stressed by this additional heating. So I want you to think as you sit through this presentation today about other examples of stressed situations that will be impacted by climate change. Okay, so returning to our number one rule, right? The impacts of climate change will be most keenly felt by systems that are already stressed in today's climate. Okay, so here is a stressed situation that was ongoing in Australia over the winter. So Australia is a region similar to the Western U.S. that just has seasonal drought every year, um, and their winter is our summer and vice versa. So December here, that's like June here. So this is kind of the beginning of summer. Um, December of 2019 of last year was the driest and hottest December on record. The average temperature was almost 6 degrees Fahrenheit or 3 degrees Celsius above normal. 2019 was the hottest and driest year on record in Australia in over 100 years. Um, and what happened was that we had extreme fire danger in Australia. And so, right, this is a stressed system, right? Australia is already struggling to deal with fire danger. And fire broke out in Australia and it engulfed the whole country. Billions of dollars worth of damage done, catastrophic fires, uh, burnt down cities, destroyed wildlife, destroyed ecosystems, in in a really big way. Air pollution became a huge problem because there's just these giant plumes of smoke. Air pollution thousands of miles away from Australia was impacted. So people were wearing masks long before coronavirus out in these regions just because of the air was so toxic to breathe. Okay, so there's a stressed system in Australia. Your participation grade for today is that I want you to come up with another example of a stressed system, and I want you to explain why this is a stressed system. So, what aspects of this choice you're going to make it particularly vulnerable to a shift toward a warmer world, and how will your example be negatively affected by warming temperatures? Right, so a day like today when I'm looking outside, it's sunny, it's pleasant, it's 50 degrees Fahrenheit, a nice April afternoon in Albany, New York. Right, warming a few degrees right now is probably not going to make that much of a difference on my everyday life. Right, so that is not a stressed system. What is a kind of situation where warming will make a difference? And I'm going to give you several examples that you can think about in the rest of this. What I would answer based on what I just did is that my stress system is wildfires in the western US that occur every summer and fall when it's hot and dry. And the reason that this is a stressed situation is that this situation is already problematic in today's climate. It kills people, destroys ecosystems, destroys homes and towns, and more. With additional warming, vegetation will become even drier than it is today, leading to more fires. So that would be how I would answer the two questions that are in your participation grade for today. You shouldn't take my example. You can take any of the other examples we're going to talk about. Okay, so as we look through the impacts of global warming, we're going to say that the most certain impact of global warming is warming, right? It's going to warm up. So let's talk about heat waves. So I had you read a Wikipedia article about the 2003 heat wave that occurred in Europe. So heat waves, a lot of people are surprised to learn, they are the most lethal type of weather phenomenon in the US. Okay, annual average deaths due to heat in the US alone are over 2,000 people. Over 2,000 people die every single year in the United States because of exposure to heat. Floods, only 880. Hurricanes, way less, 150. The Chicago heat wave that happened in 1995, a single heat wave in 5 days killed 739 people. So we're talking about something that is already a stressed situation in today's climate, right? So we already have heat waves being something that make that are difficult for us to deal with. A couple of the reading quiz questions, right, about that 2003 European heat wave give you some examples of things that happen as a consequence of the heat wave. So in this individual heat wave, there was 8 consecutive days with temperatures of more than 104 degrees Fahrenheit in this region in central France. Do most homes in this region have air conditioning? No, they do not. So this is a pretty temperate climate most of the time. So this is a place where most people don't have air conditioning. In Portugal, 5% of the country and 10% of the countryside were destroyed by fires. In Switzerland, as a result of melting glaciers, there was landslides. So all this water came down. It made the ground very wet, and that created landslides. So just like chunks of mountain that slid off of the mountain, and that can be pretty devastating if you say live at the base of the mountain and you get covered in mud. In the UK, the tarmac, so that's the asphalt on the M25, which is a major road that goes around most of London, it melted. It got so hot that it melted. It didn't like it would re-solidify later, but it becomes squishy. So if you remember, like asphalt is just made out of oil, like it's a petroleum-based product, so it has a melting temperature. So it got squishy, and they had to shut down the road because cars couldn't drive on it. Yeah. What happened to the local wine and grape and wheat harvest during the heat wave? The wine grape harvest actually did better. So I think it said that it was a smaller than normal harvest, but the grapes were of exceptional quality. And so I put this up here to try to paint a picture that says actually not all things that happen as a consequence of warming are negative, right? There will be winners and losers. We tend to focus more on the losers because we're trying to think about our future and prepare for the worst case scenario. Okay, so so I'm going to emphasize some of the negative impacts, and overwhelmingly, there's more negative impacts than positive impacts, and maybe think about why that might be. Why would there be more negative impacts of climate change than positive ones? The biggest thing that I think of as a response to that question is that we are adapted to live right here, right? So right, New York City is built at sea level. So if sea level goes up, land will still exist. You just have a new shoreline. So but that's a really expensive thing to do, to think about moving a city back from the coast where it is right now. So right, we've built our infrastructure around the climate that we're currently living in. So if the climate changes, then that's going to be something that has more of a negative impact than a positive impact. When this heat wave happened, there was maybe some foreshadowing of some food security issues that maybe we'll have in the future. So during that 2003 heat wave, where it was 3.6 degrees warmer than average, that's right in line with what we expect a normal summer to be toward the end of the century. So we can kind of use this heat wave as maybe something that previews a summer in the future that won't be a warmer than normal summer, that'll just be a normal summer. So this is what we need to plan for. France and Italy had 30 to 50,000 people dead just in those two countries alone due to heat. Italy had 36% drop in their corn. Maize is corn. France, 20% drop in corn, 25% drop in fruit, 21% drop in wheat. And by 2100, similar temperatures should be the norm throughout the tropics and subtropics, just due to normal things, right? So this extreme heat wave will be a normal summer by the end of the century. What does that have? How does that have an impact, right? So okay, this is the share of the population that is currently undernourished. So here's another stressed situation. Right? We have, in particular, tons and tons and tons of countries. Most of them tend to be concentrated near the equator and in the tropics and the subtropics, where the population is currently malnourished or undernourished. So they already have issues getting access to the food that they need to thrive. So the red here are countries where 40 to 60% of the population are undernourished. The orange here is 20 to 40%. So the poorest populations in the world already have issues getting food. And here's how that changes in the future. So it says climate change, I'll read this title, will depress agriculture yields in most countries by 2050. So this is the changes in agricultural productivity by 2050. And so red here is that we expect that agricultural productivity goes down by the year 2050. And you see that it's these same regions near the equator that are already undernourished that are the most red regions. Okay, so the reason for this is that these are places where it is already arguably too hot to grow the food that they need, especially when there's a heat wave. So if you warm up the temperature, geez, you've warmed up the planet and you've now made it harder to grow these crops. You can see that actually up in the mid latitudes where we live, a lot of these places are even green. So, and actually, if you look at New York State, we are right on the border between the reds and the greens. So this might be a place where New York State actually wins, right? Our climate is a very cold climate. If we warm by a few degrees in the summer, maybe we need to change what crops we grow because some of the crops that we grow now might not be adapted to a warmer world. But we can just grow what Georgia's growing now, right? So we can grow warmer weather crops. And then also our growing season will get longer because we now have fewer days that are below freezing as we warm. So a lot of the mid-latitude climates might be winners in this sort of situation. But a lot of the low latitude near the equator, so the tropical climates, will probably be losers. And unfortunately, it turns out that most of the poor nations of the world are in these low latitude equator tropical regions. Another stressed situation is this concept of urban heat island. So cities are actually warmer than their surroundings. So you might not have known this, but New York City is actually like 3 or 4 degrees hotter, Fahrenheit hotter, than the suburbs around New York City. And this is because of an effect called the urban heat island effect. And you can experience this effect if you ever kind of walk on a blacktop on a hot day. So cities are covered in blacktop and concrete and lots of heat producing things. Like our air conditioner, it blows cold air into our homes, but as a consequence of that, it blows a whole bunch of hot air out into the environment. And so, right, our cities are hotter than they would otherwise be because of this. Okay, so cities are already stressed situations, right? It's already harder for a city to deal with a heat wave than the surrounding environments. You throw on top of that an additional warming, and that's an additional stress. It's going to make it even harder for them to identify. These photos here are actually thermal images, so the colors indicate the temperatures. And the warm colors are hotter temperatures, and the cool colors, like the blues and the greens, are the colder temperatures. And so you can see right here is like a park that's surrounded by buildings. And you can see that actually the park is much cooler than the buildings that surround it. That are all right. We see kind of blues and greens in the park, and reds and yellows in the buildings around it. So an example of why we have this urban heat island effect. Okay, so we've got that heat waves are hard to deal with in today's climate. Let's think about where we are going with heat in the future. So these are some projected changes in temperature under a high emission scenario. And just while I'm thinking of it, with this and more or less every PowerPoint presentation that I've done throughout the semester, I put links to citations in the notes sections of slides. So you can always check the notes section for a citation, and that might be useful if you want to use some lecture materials for your final essays. If there's ever anything that's not cited, sometimes I forget and I get lazy. You can always send me an email, and I will let you know where that information came from, so that you can cite things more appropriately. Okay, so where we are is in the northeastern U.S. There we are. The change in the coldest day of the year in a high emission scenario. So this is we keep doing what we've been doing is 9.5 degrees warmer than it used to be. So that sounds great, right? So that 5 degree Fahrenheit day is now a 15 degree Fahrenheit day. That is a huge change in how much snowfall we get. So a lot of our snow falls, between 25 and 30 degrees Fahrenheit. Well, if you warm the world by 9.5 degrees, you warm that coldest day of the year by 9.5 degrees. Maybe some of that falls as water. Has big impacts on how our rivers and our streams behave because snow falls and it doesn't get into the rivers immediately. Right? It takes a while to melt all that snow, but when rain falls, it goes immediately into the rivers and it can cause issues. Change in the coldest five day 1 in 10 year event. This is like the hottest heat wave in 10 years is 15 degrees warmer. Change in the warmest day of the year is 6.5 degrees warmer. So right now in Albany, the hottest day of the year tends to be about 95 degrees Fahrenheit. So 6.5 degrees warmer than that is, instead of 95 degrees Fahrenheit, 101.5 degrees Fahrenheit. So that's a big change, right? So on a day like today, when it's 50 degrees outside, 6.5 degrees, not a very big deal. On the hottest day of the year, on an already stressed situation, when we already have all these deaths, 6.5 degrees is a big difference. Change in the hottest 5 day 1 in 10 year event. So the hottest heat wave in 10 years is 12 or 13 degrees. Okay, we have already experienced changes in our weather. So this is an example of how we break hot and cold records. So it's not true that we've stopped having record cold. We've absolutely continued having record cold, and we expect this to continue. We will continue to have extreme cold. We just have more extreme hot than extreme cold. So that's what this figure is trying to show us. Okay, so in the 1950s, the red bar shows you how many heat waves, how many record hot days we had in the 1950s, and the blue bar says how many record cold days we had in the 1950s. And this ratio here says it's 1.09 to 1, which means that for every 11 hot records that we had 10 cold records. And that's more or less what we expect in a climate that's not warming, right? We should have just about as many hot records as we have cold records. And that's what we're seeing here in the 50s, 60s, and 70s, where like the red bar and the blue bar are about the same size. In the 60s, we actually had more cold records than hot records. In the 70s, we also had a little bit more cold records than hot records. In the 80s, we had a little bit more hot records than cold records, but all four of these decades are more or less, we're having about as many hot records as cold records. Into the 90s, this became quite a bit more hot records than cold records. Into the 2000s, we were breaking 2 times as many hot records as we break cold records. So for every one time we have the coldest day of the year, we have 2 hot records that we break. And this has continued into the 2010s, but I've never found an updated version of this figure, so I just have to keep going with it. So we now break twice as many hot weather records as we break cold weather records. And an important thing to bring home about this, and actually this is a great thing to reference when you're answering a question. I think I have a question about like Aunt Sally and Uncle Joe are having an argument over Thanksgiving about whether global warming is real, and Aunt Sally says that global warming is real because her tulips bloomed earlier than they ever have before, so it must be hotter than normal. And Uncle Joe says it can't be because this was a really cold fall and he doesn't remember any winter that was ever so cold. And I think the question asks, why are they both wrong, right? This is why they are both wrong, right? We have extreme heat and extreme cold, even in a climate that is warming. So we can break a hot record just like we can break a cold record, and we can do it next week. We're just more likely to break a hot record now than we are to break a cold record. Okay, so let's look at some forecasts of future warming in another kind of business as usual emission scenario. So we don't make really big changes to our economy to lower our emissions. So this is currently the number of days above 100 degrees Fahrenheit current, so the 90s and the 2000s. And you can see like down here in the desert Southwest, they have 50 or more days a year right now where there is above 100 degrees Fahrenheit. We're over here and we usually don't have any days above 100 degrees Fahrenheit. So we kind of have them hottest places clustered in the Midwest and the desert Southwest over here. There we are in the 2060s. And there we are by 2100. So I'm going to step through that again. So there's 2000s, 2060s, and 2100s. So you can see that this is going to be a huge change for most of the U.S. Right, 100 degrees is kind of this is a pretty important cutoff. Above 100 degrees is really hard for people to live in without air conditioning. Below 100 degrees is pretty hard as well, but right above 100 degrees, and you really start talking about people are dying because of this. Crops don't grow, fires become bigger and bigger issues. So we are moving into, geez, this is like the whole southern U.S., the whole like south of the middle, 50 or more days a year above 100 degrees. That's like 2 months a year, every day above 100 degrees. Okay, so what we do affects the future warming. So what I just showed you is projections of warming if we continue in a business as usual scenario. But what we have learned, if we've learned nothing in this last month, is that what we do affects things, right? So, we've all looked at talking about coronavirus stuff, flattening the curve, right? And how we behave determines whether we kind of whether everybody gets infected and the hospitals get really overwhelmed, or whether we can kind of spread out the rate of infections, right? We have control over the future. The same lesson is true for climate change, okay? So why do we not know how much it's going to warm? Because we don't know whether Earth and human civilization is going to make choices right now and in the immediate future to really change the way that we get our energy. So that's what this is trying to show. So the black dots here are historical emissions. And the red lines and the blue lines are just potential paths in the future that we might have for emitting carbon, right? So this is fossil fuel emissions in the unit of gigatons of carbon. So some unit of how much carbon we emit from fossil fuels, right? And going into the future, we can follow these higher emission scenarios. And that, by the way, is what we're doing right now, right? We're following the highest of the emission scenarios that have been projected. We started making these emission scenarios kind of around in the year 2000. You can see that, we have not followed the lower emissions trajectories. We followed the higher ones. But, are we going to follow these business as usual ones, or are we going to make big actions now? Right, and so what we do affects future emissions, and what we have been doing has also affected future emissions. Okay, so people are talking about, this data just came out about a week ago, saying that coronavirus might trigger the largest ever annual fall in CO2 emissions. So CO2 emissions in the year 2020 will likely drop by more this year than they ever have in the history of human civilization. Okay, so just to put this in perspective, so down here on the x-axis is showing how much global emissions dropped, and on the y-axis is the blue lines here, blue bars here, are the 5 biggest single drop years. So you can see that the 2008 financial crisis, we dropped by almost 500 millions of tons of CO2. The Spanish flu in 1918, that was another big drop. The energy crisis in the 80s, that was another big drop. The recession in the early 90s, the Second World War, that was another big drop. So these are the 5 biggest single years that we've dropped our CO2 emissions. And here's the most recent forecast for what we're going to do in the year 2020. So lack of economic activity in India, the US, China, the European Union, and then global oil, right? Nobody's driving anywhere, nobody's flying anywhere. So global oil is going way down. Prices at the pump are as low as I have seen them since I can remember right now. Um, right, so we're talking about having a 5.5% drop in CO2 emissions just in 2020 relative to what it was like in 2019. And this is caused, of course, by global recession, which is probably not the way that we would like to reduce our emissions, but is a huge and very dramatic change. And it seems like we are doing so much right now that should have a huge impact on things. But you know what? Even if this forecast is what ends up happening in the year 2021, CO2 concentrations in the atmosphere will still go up. Because even with this 5.5% drop, it's like you kind of think about it as like a bathtub, right? We have the faucet on and water is coming into the bathtub. That's like us emitting carbon dioxide into the atmosphere. The faucet is on and water is flowing out of the drain plug. But if the faucet is on so fast that it's coming in faster than it can go out, then your bathtub will get more and more filled up as it goes through. And that's what is happening. So this year we're going to be turning the faucet down, but even turning the faucet down isn't going to be turning the faucet down enough to prevent CO2 from accumulating in the atmosphere. And this is kind of a sobering thing for me because, right, it shows that like we think so much about our like lifestyle projects and how we can change our actions to make to lower our carbon footprint and our environmental footprint. Right. There's like I am doing as much as I could possibly imagine doing to lower my environmental footprint right now. But in order to put this but it's still not as much as probably need to do in the future. And for me, this really just underscores that we need support from higher than just an individual level. Right? I need someone to come and say, you want to insulate your house better so that you don't have to heat as much. Let me help you pay for that. You need someone to come and say, you want to not have to go through as much oil in your car. Let me help you support that by subsidizing the cost of an electric car for you to buy. A city needs to say, well, geez, let's make major investments in our public transit and get all of our buses to be electric, such that it's good enough that people can use it and they feel comfortable getting rid of their cars. Like those are the types of things that we need that are support not just on this individual level, but that come from higher up. Okay, and I'm going to read this quote here, which you might have read by now. It says, to put the potential 2020 coronavirus effect in a broader climate context, it's worth adding that global emissions would need to fall by some 7% every year this decade in order to limit warming to less than 1.5 degrees above the pre-industrial level. So a lot of people have set at 1.5 degrees is sort of how much warming would be okay. So we don't want to try to avoid warming above 1.5 degrees. So this 5.5% reduction we're expecting in 2020 is still not enough. We need to get that up to 7.5% every single year. So just to kind of put that in context. Okay, so that's some things about heat waves. I want to talk about one other impact of warming, which is sea level rise effects on coastal cities. And actually, I just remember before I do that, I want to show you this link about airplane data. So we'll do this. So I'm going to show you every one of these dots here is the location of an airplane flight on a Tuesday in March of 19 compared to a Tuesday in March of 2020. And so we'll just kind of cycle through this. You can watch the airplanes moving. So you want to talk about why global oil consumption is going to go down. Right? That is why global oil consumption goes down. There's just no airplanes that are flying. There's no cars that are driving, transportation is taking a big hit. Okay. So let's talk about sea level rise, specifically on New York City. Okay, and I want to talk about Hurricane Sandy. So one thing that you might have heard is that in the future we expect hurricanes to become more intense than they are today. I actually don't want to talk about that at all. So that's true. When the climate warms, there's more water in the air. You can think about like it's more humid in the summer when it's warmer outside. So like a single storm will produce more rain in the future. And I want to set that aside. So yes, that's true. We do expect that in the future, not necessarily that there's more hurricanes, but that the hurricanes that we do have will be more intense than they are today. So they'll produce more rain and they'll have more wind. That's actually something that's subject to some uncertainty. That's not like a guaranteed, definite thing that it's going to happen and have in a big way. But you know what is guaranteed definitely going to happen is sea level rise. Right? When it warms up, ice melts. So ice that used to be on land ends up in the ocean, and that causes the ocean water to go up. That is 100% definitely going to happen. So what I want to talk about is let's use Hurricane Sandy not as something that happened because of climate change or global warming or blah blah blah. Let's just think about what would have happened if Hurricane Sandy, which clearly can happen in the future because it happened already, happened with additional sea level rise. So what if we had 2, 4, or 6 feet of additional sea level rise? I think most projections say that most likely sea level will go up, between 1 and 2 feet. But some of the upper end projections put sea level rise as much as 6 feet higher in the future than it is what it is right now. This is some tide data about what happened in Hurricane Sandy. The blue line here is that tides go up and down. And if you've been to the coast, the ocean, you know this, right? There's high tide and there's low tide, and it looks like in this location that I'm looking at here, right? There's about 4 feet of difference between high and low tide and where the sea level is. And so actually the red here is what happened to sea levels as Hurricane Sandy came up. Okay, so the normal high tide would have been about 2 feet above sea level, above sort of normal sea level, and the actual high tide for Hurricane Sandy was 13 feet. Okay, but if you put an additional 2 feet of sea level rise here, that's a huge catastrophic impact. Not from a storm that's some sort of crazy can't happen in the future storm, but from a storm that we have already had, like Hurricane Sandy. So damage from Hurricane Sandy was almost entirely due to storm surge. And this is why up here upstate, we really didn't have much impacts of Sandy. We have had other impacts from big hurricanes, but really not Sandy. It wasn't, right, so it was an issue with storm surge. So this is that like there's winds going around the eye of this hurricane, and those winds basically blow a big mound of water. And as that big mound of water hits the land, it just kind of pushes a bunch of water up onto the land, and that causes flooding. Rainfall from Sandy wasn't really actually all that significant. It was mostly just places that are right on the water getting just inundated with this massive storm surge. And here's what that looked like. So here's Tuckerton, New Jersey, right after Hurricane Sandy, and you can see that these houses are all underwater. The plaza along along Water Street and Lower Manhattan, the subways flooded. Locations due to Sandy's storm surge, right in the current floodplain, in this sort of area here, 400,000 people live in the current 100-year floodplain. Let's talk about what a 100-year floodplain means. A 100-year flood means that there is a 1% chance of that of you getting flooded at that location every year. But that doesn't mean that if you live there for 100 years, it happens one time. It means that we had a 1% chance of it happening this year. We have a 1% chance of it happening next year. We have a 1% chance of it happening the year after that. Um, but just because you had a 100-year flood this year doesn't mean you can't have it next year. You could have it again next year. It's kind of like rolling the dice. So if I roll the dice and I get a 6, okay, I rolled a 6. If I roll the dice again, that doesn't mean I can't get another 6, okay? I could get a 6 just as easily as I could get a 1. The same thing is going on here with this. Okay, so if you live in a 100-year floodplain, that means that you have a 1% chance of having that flood in a year. That seems like a pretty low risk. A 26% chance of having a flood in 30 years. Most mortgages are 30-year mortgages. Okay, so that is like saying if you buy a house in a floodplain, you have a 1 in 4 chance of having a flood in your home during the lifetime of your mortgage. Should you buy flood insurance? You should buy flood insurance, right? A 1 in 4, that seems a lot worse than a 1 in 100. If you live in that home for 60 years, that gives you a 45% chance in 60 years. So that's almost 1 in 2, right? Chances are very good that you will see a flood during your lifetime. And this current floodplain map is not forecasting into the future. This is not adding 1, 2, 3 feet of sea level rise that's going to happen into the future. This is just right now. So how is New York City going to plan to deal with this? Okay. 100 years, New York City looks nothing like it did 100 years ago. Okay. It will also look wildly different in 20, 50, and 100 years. So fixing this is not rocket science. It's just a question of will. And New York City, as much as any city in the nation, is taking this issue of sea level rise very seriously. And I want to show you a couple of clips from an excellent video. So this video is called Sinking Cities, and it's linked down here in the lower right-hand corner. And I just want to show you a couple clips. So it's a PBS documentary series that steps through 5 different coastal cities, spends an hour on each city, and what are some of the adaptation plans that they have in the pipeline to deal with planned sea level rise. So I'm going to show you some clips about the one from New York City, and we're going to start here.
After Sandy, Horton's data was used in modeling to see what New York would look like with 6 feet of sea level rise by 2100.
So this is a satellite map showing New York City without any flooding. Shown here is Broad Channel, the Rockaways, Lower Manhattan, and over here is Staten Island. If you get 6 feet of sea level rise, the everyday average high tide is going to start flooding a lot of neighborhoods. It's high tide in 2100. This is now showing tidal flooding of places like South Street Seaport, Lower Manhattan, a lot of flooding around Jamaica Bay, also on Staten Island. Hundreds of thousands of people being flooded at that point. It's uninhabitable when you start getting flooded so many times per year. That's tidal flooding, but then there's also storm surges. We can also look at what 2100 would hold if we had a very severe storm like Hurricane Sandy, plus 6 feet of sea level rise. A much larger percentage of the coastal zone is flooded. The west side of Manhattan, the Tribeca District, Wall Street, Battery Park, Lower East Side.
Sandy flooded 51 square miles, 17% of the city. With 6 feet of sea rise, those numbers would be closer to 100 square miles, or about a third of the city underwater.
This kind of flooding would be catastrophic. There's massive infrastructural elements for a city of 8 million people that are in the flood zones. Transportation system, the tunnels, the subways, the electrical system. And of course, a lot of these things were flooded just by Hurricane Sandy. So if you envision 6 feet of sea level rise, then a great deal more is at risk at that point. The whole city could be disabled in this kind of flood scenario. It's almost certain if we don't reduce our carbon dioxide emissions that we'll have sea level rise of that scale in the 22nd century. New York City's 300 years old. At this rate, we won't make it to another 300 years.
Okay, so I want to skip ahead here to talk about some of the challenges. And also, he's talking about 6 feet of sea level rise. And I want to emphasize that 6 feet of sea level rise is very unlikely. 1 to 2 feet of sea level rise is much more in line with what typical projections are for the end of the century. But it turns out that future sea level rise is something that is pretty uncertain. So, how much ice melts is not super well known. So there's kind of big uncertainties around, well, is 6 feet of sea level rise possible by the end of the century? And that's not really a very well known thing.
My name is Dan Zarilli. I'm the Chief Resilience Officer and Senior Director for Climate Policy Programs here in the Mayor's Office. There's been a lot of activity to make sure that we are more aware of what it means to live by the coast, and that sometimes you may get wet, but we're continuing to invest and make sure that we are able to bounce back quicker from those events, and that we're building a stronger New York City at the end of this. The vulnerabilities aren't just something that's going to show up in 100 years. They're here, they're now, and we need to invest to mitigate those risks. And that means that we're looking at a full range of coastal defense investments. We're implementing them, new building code regulations, new zoning code regulations, upgrading our infrastructure.
In the search for solutions to save the city, Dan Zarilli has turned to the private sector.
We are not an infrastructure-forward country right now.
Vishaan Chakrabarty is one of the architects and urban thinkers who is tackling the problem head-on.
The last time we were was under President Eisenhower.
The highway construction program initiated by Ike is the biggest peacetime enterprise ever undertaken. It will cost tens of billions.
That was the last time this nation moved a quantum leap forward in terms of its infrastructure, and we haven't done it since.
The elimination of waste spending made a balanced budget possible.
As much as I love New York, our biggest problem in my mind is that we have substandard infrastructure that's over 100 years old. I think we need to really step back and holistically look at all the infrastructure in the city. Do we have train stations that function properly? Do we have subways that can run in these situations? In the world's richest country and the richest city of the world's richest country, are we going to say that we're not going to do something about this?
The question remains, does New York City really need to spend huge sums on expensive mega projects to protect itself from rising sea levels? The answer may lie in a vault in Massachusetts. Historical records reveal evidence of previous megastorms in New York, and researchers look for patterns to determine if they are getting more frequent and worse.
This is the C4 Samples Lab. It's a national archive of all the sediment cores that have been taken over the last several decades.
Jeff Donnelly is a senior scientist at Woods Hole Oceanographic Institution.
They're samples from all over the world, tens of thousands of them. We maintain this archive so that scientists can come and resample cores that may have been taken long before they were born.
These core sediment samples were taken by scientists in New York dating back to 1721.
One of the things that makes New York especially vulnerable to hurricane strikes is the sort of shape of the coastline there. So you've got the bight where New York and New Jersey come together. As a storm comes up the eastern seaboard, it's focusing water into that bight and causing greater levels of storm surge.
Just like tree rings can tell the story of climate change, core sediment samples offer clear signs of powerful hurricanes across the past 300 years.
You can see these really distinctive sand layers here that are deposited within the salt marsh peat. And it's these layers that tell us about the high energy event that occurred. So it's hurricane waves and storm surge overtopping the beach, transporting the beach sand into the salt marsh. We already had well documented the 1821 hurricane, but didn't really have a very good modern analog for which we had modern measurements. Hurricane Sandy provided an opportunity to do a comparison with these earlier events. We know from the documentary record that storm surge for 1821 was actually even higher than Sandy. It was probably about 14, 15 feet worth of storm surge. The 1821 hurricane hit when sea levels were about 2 feet lower.
Every century, the city gets slammed.
You don't even need a bigger and badder storm than 1821. You have 1821 come back, you've already got to add 2 feet to that just because of the sea level rise that's occurred since then.
Donnelly's findings confirm Superstorm Sandy was not the exception, but the rule, common to every century. In fact, the storm surge in 1821 was 1.5 times the height and strength of Sandy.
They're more of an order of once every 70, 80, 100 years.
New York's population then was just over 120,000 people, most of whom did not live on the water's edge.
In the next century, sea levels forecast to rise at least 3 more feet. So you can imagine how much more infrastructure and people are at risk as every foot sea level rises.
Donnelly's findings confirm that New York has always been hit by hurricanes. The next storm is coming, and more people than ever will be living along New York's coasts when the city floods. This is how New York City's coast looked in 1821, when the last megastorm before Sandy hit. Stark, wild, flat, and vulnerable. It's a salt marsh in New Jersey, 20 miles from Manhattan.
It's interesting to know that sea level goes up and goes down, but if you want to correlate it with climate, you need to know when.
Horton and his team also use core sediment samples to research the prehistoric climate of New York. But instead of focusing on the patterns of sand layers, they look at microscopic organisms to determine if sea levels have risen dramatically in the prehistoric past.
The 4 meters of sediment represents approximately the last 2,000 years of Earth's history. Nice, then. We take these cores back, and we try and record precisely how sea level has changed. Has it accelerated? Has it decelerated? And then correlate those with changes in climate. The microfossils that we're looking at under the microscope are single-cell organisms known as foraminifera.
Went a little farther on that than I meant to go. I want to skip ahead to one last thing. Talk about an infrastructure idea that is actually well on its way in development, called the Big U.
New York for the 22nd century. This is what's called the Big U. It's an ambitious mega project that would protect the $500 billion business sector in Lower Manhattan, the epicenter of the American economy.
My name is Kai Uwe Bergman.
Uwe Bergman is an architect who leads the Big U project.
We have proposed 10 miles of contiguous flood protection, stretching from West 57th, 58th Streets along the entire coastline to the tip where Battery Park is right now, and then back up the East River to the 30s. That would protect all of the geography that is currently below the flood line.
The Big U is a massive seawall, in places 20 feet high, that would protect the most vital business district in the U.S. from sea level rise of up to 15 feet. Its surface would be primarily parkland, with sports facilities, playgrounds, and bike and walking paths all along the 10 miles of coastline it is designed to protect.
In the case of New York, there was a realization that climate change is something that we need to address. You can think of the Big U as actually a giant gutter, because it also is dealing with all of the rain that's hitting the streets while a hurricane event or a storm event is happening. The Big U has also a contiguous bike trail, so if it were all built out, all 10 miles, you could ride a bicycle for 10 miles and never cross a street. You could say that the coastline of Manhattan is actually going from a working waterfront to one that is about leisure, it's about health and well-being, and making the waterfront accessible.
The Big U will be realized in stages, the first being a 2.5-mile stretch on the Lower East Side. The city has approved the plan with a budget of $305 million. Trevor Holland lives in a neighborhood the Big U would protect. As a lawyer and a resident, he took part in meetings with the developers, who say the project would protect 2 bridges from the rising sea.
This neighborhood has planning fatigue. We've been through dozens of meetings about what we're going to do, we're going to change this, we're going to add this, and a lot of those plans wind up on the shelves. We go through this process of trying to figure out a way to protect the neighborhood, and you wind up with a nice, big, glossy booklet that sits on the shelf, and nothing happens.
That's not Holland's only problem with the Big U.
We fought so long to get access to the waterfront, and now one of the solutions that they're proposing is to basically close it off. We're going to build 10-foot walls, all made of concrete, and you'll be protected, good to go. We've been asking, is this the only solution? Is there anything else? Or are we just looking at walls? I mean, what have other cities done?
Holland's not alone. There are others who think the Big U is a step in the wrong direction.
In Rotterdam, they are designing underground parking garages. So if they know a storm is coming, they evacuate the cars, and they build that parking garage so that it can be a water holding tank that holds millions of gallons of water, so that water doesn't go out into the community. And then when the water recedes, they have a mechanism to pump the water out of the parking garage. The parking garage does double duty. So there are ways to design around these problems. I don't think the answer is you're going to retreat from all of Lower Manhattan. We have to figure out how to build things more resiliently.
Geophysicist Klaus Jacob has other concerns.
How high do you make those seawalls before you are in a prison? And that's not a sustainable solution.
That's a dystopian picture. It's just a wall, and most of it, in fact, is just a concrete rebar wall. And I think that going in that direction makes our cities more brittle. So easy for that wall to break. I mean, I worked in New Orleans for 8 years. Walls break. Unexpected things happen. A barge whacks up against it. There's always something unexpected.
Hill's greatest concern is that all walls eventually have to come down. She believes in building in layers, with every generation contributing to the work done by the last.
A wall, that's rigid, that's fixed in place. The design is only for that specific location. We should spend that same amount of money to put things in place that can be added to. We need to build the foundation for future generations.
Urban architect Pippa Brashear agrees that living behind a wall is a future she cannot imagine.
It's fundamentally going to change the culture. And is that the New York City we want to live in? It's not the New York City I chose to live in. One of my greatest fears for the future of New York City is that we won't get past that protect question.
I'm a little bit of a skeptic of anything that says, oh, we're going to keep the water out over here, because it's going to go somewhere. It was conceived of as a big giant wall, and they might have said, well, we're going to put some grass on it so it'll look nice, but it's still a big giant wall. This notion that we're just going to build a giant fence around New York City and keep this from happening is not either practical or, in some ways, ethical.
It's anything but a dumb wall.
Kai-Uwe Bergman welcomes others to come up with a better idea.
It is going to be a place that a person can actually go, inhabit, use 100% of the time, and then be reassured that it's actually protecting them against the sea surges.
He says a short-term radical solution is better than none at all.
I think the biggest risk is not doing anything. Many of these communities have heard repeatedly that something would be done. And I think that the biggest fear is that another storm event would come and flood them out of their homes again, and they have to deal with the loss.
Wood Channel is a little island in Queens in the middle of Jamaica Bay. It is a tiny place. I don't think anybody ever heard of it. Unless you live in the area. I talk a lot of.
Okay, and that's all I was going to show of the video. But if that is something that appeals to you, you can look at the link and watch the whole hour-long video because it's great. There's at least the whole video is great. Okay. So some more impacts of warming. Okay, so we've talked about temperatures rise and heat waves and some of the consequences of heat waves. We talked about how sea levels rise. Other things, ocean acidifies. So when carbon dioxide is released into the air, that ends up in the water. And when it ends up in the water, the carbon dioxide turns into carbonic acid. So it acidifies the ocean. And actually the chemistry of that is not too different than what we talked about for sulfur dioxide. So when you release sulfur dioxide and it gets in the rainwater, it makes sulfuric acid, and that makes acid rain. Just like when you put carbon dioxide into the water, it makes carbonic acid, and that acidifies the water. We also have changes in the water cycle, changes in extreme weather, and a lot of things that we're not going to be able to get to. And I want to return at the end of this to this idea of the impacts of global warming are most keenly felt by situations that are already stressed in today's climate. Okay, this number one rule that will absolutely show up on the module test coming up. Okay. Right, so these are things that we can think about compounding the effects of climate change, making it more difficult for ecosystems to adapt. So pollution, right? Air being dirty kills tens, hundreds of thousands of people in the world every year. And we watched a video about this earlier this week about how in the midst of this coronavirus crisis, a silver lining is that tens of thousands of people have not died because the air pollution that is usually there because of all the fossil fuel burning that we do isn't there now. So it's killing fewer people in that way. Habitat fragmentation, right? So as it warms, species that are adapted to live in a certain climate, they can't just migrate 1,000 miles north to a more hospitable climate. Invasive species, overfishing. So, right, we already have an issue with overfishing our waters, and as we add the additional stress of warming in the water, right, those fish that were already struggling to thrive because they're being fished so much are now having to deal with this additional stress, which is warmer water. There's so many more ways to look at this, and unfortunately, we're out of time in this semester, so we're done talking about some of the impacts of warming. I do want to point you to a really great resource that you might use in your final essays. This is the National Climate Assessment. So it's linked on Moodle under the materials at the very bottom of the Moodle page for the final exam. It's also linked in this PowerPoint presentation, so you can click on it there. The National Climate Assessment is a very long report. I don't recommend that you read the whole thing. I know that I certainly haven't read the whole thing. But what it does is it focuses on a lot of regional impacts. So it's like certain regions of the country. And so if you are, say, picking a state and you are asked to, say, give some impacts of that state, the climate assessment, National Climate Assessment might be a great place to look for that. Also, if you're picking a state, you might just check and see if your state has a climate adaptation plan. I know New York State has plenty, and I'm happy to point you in those directions. Most states have some sort of climate adaptation plan as well that will overview some of the impacts that they're most concerned about. Okay, and that is it for today's class. So make sure that you have the reading quiz in if you haven't already done it, and the participation grade for today, that picking out the stressed situation and explaining why it will be something that's negatively impacted in a warmer world. And I will see you next week.